In this video, we're going to look at an introduction to radicals with the definition of the square root and the cube root. So we'll start with the square root, which will begin by reviewing the definition of the square. We know when we square a number, we multiply that number by itself. So in this case, a times a would be the base, 2 would be the exponent, and the number we get from that number would be the square of a, or a squared. Example, let's say we start with a base of 4. When we take its square, we get 4 squared. 4 times 4 is 16. So we want to try to reverse this process to define the square root. And the symbol for the square root is this. This is the radical. And if we take the square root of a number, let's say b, we can set up a similar picture. But remember, we're trying to reverse this process. So we're actually going to start with the square, and we're trying to find the base of that square. The base now over here is going to be the square root of b. Let's look at an example. Suppose we were asked to evaluate the square root of 16. Whenever I'm evaluating a square root, I'm asking myself, what number squared is equal to this? So what squared equals 16? And we just saw from the previous example that 4 squared is equal to 16. So the square root of 16, according to this definition, should equal 4. There is one important question we should ask here. If we think of this square root as an operation on a number, is this well defined? In other words, will I always get exactly one output from this operation? So can you think of any other numbers in here that would work besides 4? And there is another number that works. Negative 4 squared is also 16, because we get a double negative. Negative 4 times negative 4. So this presents a slight problem. Should we define the square root of 16 to be 4, or should we define it to be negative 4? The way we're going to fix this is we're going to define 2 separate square roots. The positive one is going to be called the principal square root, and that's just going to be the square root symbol. So the square root of 16 is equal to 4. And then we're going to define a negative square root, and it's just going to be the opposite of the principal, or the negative of the principal. So the negative square root of 16 would be negative 4. So I like to think of this radical symbol itself as always representing the principal or positive square root. And then if there happens to be a negative in front of it, that would make it the negative square root. But just so you don't have to decide, the square root symbol itself is always the principal. Now before we go on, I'd like to point out that 16 is an example of something we call a perfect square. When you're talking about integer perfect squares, it means it can be written as the square of another integer. So here are some other examples of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. And you can see there are corresponding square roots. These are the principal or positive square roots. And we'll need to be familiar with these later when we look at how to simplify square roots. So what happens if we try to take the square root of a number that's not a perfect square, something not in this list? For example, the square root of 5. we ask ourselves what squared is equal to 5, and we're not going to get a nice whole number this time. A little trial and error will show us that 2 squared is 4, 3 squared is 9. Since 5 is in between 4 and 9, our square root is going to have to be between 2 and 3. And you could take this further, but let's look at what a calculator would give us. The square root of 5 is 2.2360679, and this decimal keeps going on forever with no repeating pattern. It's a nice example of an irrational number. So you can't write it exactly using decimal. The only way we can represent the exact value is to use this square root symbol. And we'll learn in later videos how to simplify the square roots of numbers that are not perfect squares. But if you want to give an approximate decimal, you can round this. Let's say we wanted to round to the nearest hundredth. We would get approximately 2.24. And you could try squaring this number, and you would get something close to 5, a little bit larger since we rounded up. One last issue we need to address for square roots. What about the square root of a negative number? We ask ourselves, what squared is equal to negative 25? Well, we know 5 squared is positive 25. And negative 5 squared is also positive 25. We're going to get a problem here because whenever we square something, we either get 2 positives or 2 negatives. And either way, we end up with a positive number over here. The only way we're going to get a negative product is if we have a positive and a negative, but that's not a square because they're different. So the problem we have is there is no real number that will work. Later we'll learn how to deal with this using complex numbers. But for now, when we first introduce this, we usually just say that the square root of a negative number is not a real number. The square root of negative 25 is not a real number. So we get kind of an interesting picture for square roots. Let me just draw the number line here. We have the positive numbers off here to the right, and the negative numbers going off here to the left. And what we found was positive numbers had 2 real square roots. They had the principal square root and the negative square root, like 16, plus 4 and minus 4. 5 had 2 square roots, plus root 5 and negative root 5. They just weren't nice numbers. But the negative numbers, like this, have no real square roots. And 0, there's actually only 1 real square root for 0, and that is 0. Square root of 0 is just 0. We don't have to worry about principal or negative because there really is no positive or negative with 0. They're both the same. So that kind of wraps up square roots for now. Now I want to give a definition of the cube root, and we'll start by reviewing the definition of the cube. So now we're taking the third power of a number. This would be a times a times a. We get some number as a product, and that would be the cube of a. So an example, 2 cubed is equal to 8. 2 times 2 times 2. Now let's see if we can reverse this process to define the cube root. The symbol for the cube root uses the same radical symbol, but we put a little index of 3 kind of tucked in the corner there. So if we're taking the cube root of a number, be, this is the cube. That's going to go on the right side. And now we're looking for the base of that cube. The base is now going to be the cube root of b. So let's try an example of this. Let's look at an example. The cube root of 8. So we ask what number cubed is equal to 8. And we just saw that 2 to the third power was equal to 8. So the cube root of 8 should be equal to 2. Now, we should ask the same question we asked for square roots, which is this a well-defined operation? Is there only one number that's going to work here? The answer was no for square roots. But for cube roots, if you tried a negative 2 in here, negative 2 times negative 2 times negative 2, the first pair would give you a positive 4. But whenever you take an odd power of a negative number, you will always have one negative factor left. So negative 2 to the third power is negative 8. And that tells us that the cube root of negative 8 is equal to negative 2. And it at least kind of demonstrates that we're not going to find any other factors here that are going to work because it's an odd exponent. Positive numbers have exactly one real positive cube root. Negative numbers have exactly one real negative cube root. And the cube root of 0 is just 0. So all real numbers have one real cube root. It's a much simpler picture than we had for the square roots. We can also make a list of perfect cubes, just like we did with perfect squares. Here are the corresponding cube roots. We will use these later when we simplify cube roots. So let's end with an example of the cube root of a number that's not in this list. We'll consider the cube root of 18. And we can see that since 18 is in between 8 and 27, the cube root should be between 2 and 3. My calculator gives me, this is 2.620741139. This decimal goes on forever with no repeating pattern. So this is another example of an irrational number. So we could approximate that if we want by rounding it to, let's say, the 100th. And if you took the third power of this, you'd get something just a little bit less than 18, since we rounded down for this. And later we'll learn how to simplify cube roots of numbers that are not perfect cubes when you don't want to approximate.